All right, we're going to define a new operation on vectors called the cross product. Now, we defined the dot product in previous videos, and we noticed that we could take the dot product of vectors in 2D and we could take the dot product of vectors in 3D. And what we got when we did that was a scalar. The cross product is very different, and the first thing I want you to know is that it is not a scalar, but it produces a vector. So the dot product produces a scalar and the cross product produces a vector. And the second thing that's very important is that this must take place in 3D. You can't apply the cross product to vectors in 2D. All right? So those are the first two things. All right, I think we're ready to actually define the new vector A cross B. And it's going to be defined as such. So its first component is going to be A2, B3 minus A3, B2. So that's the first component of my new vector. The next one is A3, B1 minus A1, oops, I didn't write that, A3, B1 minus A1, B3. And then the next, or the last, is A1, B2 minus A2, B1. There we go. Now, you might notice that these two are similar and that this middle guy is a little bit backwards, and that is true. You might think that it should be A1, B3 minus A3, B1, but it is not. And this is the definition, and this is how it is defined. All right. Now, this might be hard to remember, so we're going to introduce some other ideas, and the first is a determinant of order 2. And it is defined to be as such. If you have a 2 by 2, so A, B, C, D, and you want to find its determinant, then it is equal to A times D minus B times C. All right, that's just how we define the determinant of order 2. All right. If we want to now define the determinant of order 3, what we realize is that it's really just a sum of a bunch of determinants of order 2. So let's define it. It's going to be, let's say, A1, A2, A3, B1, B2, B3, C1, C2, C3. What that's actually equal to is A1, so this first row, first column, and you can think about it as blocking out the rest, times the determinant of the remaining entries, so B2, B3, C2, C3. This time we're going to switch signs, minus, so this time it's going to be A2. Now we're going to block out its row and column, and then we have this remaining entries to form the determinant B1, B3, C1, C3, and then last, back to plus, we'll see we're alternating signs, A3 times this remaining determinant, B1, B2, C1, C2. All right, and so then we would just proceed by finding the determinants of order 2 for each of those 3 pieces. Now you may ask, well, why are you bringing this up at this point? What does it have to do with the cross product? Well, let's go to the next board and see if this will generate the same definition we have as the cross product. Okay, so let's remember our 2 vectors, A, which is A1, A2, A3, and vector B, which is B1, B2, B3. And let's look at the determinant where my first row is the unit vectors I, J, K, and then we will have A1, A2, A3, B1, B2, B3. Now if we find the determinant of this 3 by 3, what we realize is we get the determinant A2, B2, A3, B3, I, minus, because remember we alternate signs, the determinant A1, A3, B1, B3, J, plus the determinant A1, A2, B1, B2, K. And if we multiply this out, we realize we get A2, B3 minus A3, B2, I, minus A1, B3, this is where that flip-floppy comes in, minus A3, B1, J, plus A1, B2 minus A2, B1, K. And this is precisely the vector A2, B3 minus A3, B2, A3, B1 minus A1, B3, you see the sign distributes here, and A1, B2 minus A2, B1. And that is the definition of the cross product.